Lesson 12.5 is on simulation. In this lesson, you will learn to calculate experimental probabilities and design simulations and summarize data from simulations. So your vocabulary for this section includes theoretical probability, experimental probability, relative frequency, and simulation and probability model. So before we get into this, we need to know the difference between experimental probability and theoretical probability. So theoretical probability is what you would expect the probability to be. So if you think about a die, so you're rolling a dice, right? And it has 6 sides on a cube, right? So you've got like 1 and then like your 2, 3, etc., right? You would expect each number to have a probability of 1/6 being rolled. That would be your theoretical probability. But your experimental probability, let's say you rolled the die and you rolled it 6 times and you had 2 rolled ones, 3, 4, 2, 6, and 1. So in this case, the experimental probability, 2 was rolled twice. Oh, I completely missed. Right? So 2 out of 6 times, you got a 2, which would be 1/3. So your experimental probability would be 1/3, whereas your your theoretical was 1/6. So there could be a difference, okay? Today we're focusing more on experimental probability, but it's important that you know both of them, okay? So, for example 1, we're looking at a die rolled 50 times and the results are recorded. Find the experimental probability of rolling a prime number. So we're looking at these and we want to know which of these are prime numbers. So remember, prime numbers are only divisible by itself and 1. So 1 is prime, 2 is prime, 3 is prime, 4 is divisible by 3, 5 is prime, and 6 is divisible by 3. So I have 6, 10, 14, and 6. So those are these numbers here. Those are the number of times each of those prime numbers was rolled. So out of all of those numbers, that's the number of times out of the 50 times that it was rolled, I'm going to add those up. So I get 16 plus 14 is 30, so I get 36 out of 50. And then I'm going to reduce this to 18 over 25. And yeah. Okay, so the experimental probability of rolling a prime number is 18 out of 25 times, based off of the experiment that was conducted here. Okay, the next one is for you guys to give a shot. A spinner is spun 50 times and the results are recorded. Find the experimental probability of landing on an odd. So you guys figure this out. Okay, so the next thing we want to do is we want to be able to design a simulation. And a simulation is a way to come up with the data for an for calculating experimental probability. So there's some things we want to include in this. So the first thing is determine each possible outcome and its theoretical probability. So think about it and what the theoretically what the probability would be. Step 2 is describe an appropriate probability model for the situation that accurately represents the theoretical probability of each outcome. And then step 3 is define what a trial for the situation is and state the number of trials to be conducted. So if we wanted to design our own simulation, okay, we're going to say Mandy is a pitcher on her high school softball team. Last season, 70% of her pitches were strikes. Design a simulation that can be used to estimate the probability that Mandy's next pitch is a strike. Okay, so we're not actually calculating anything. We're just kind of setting up how we could possibly do this. So we're going to look at her theoretical probability. 70% of her pitches were strikes. So we would expect that 7 out of 10 of her pitches would be strikes. And then we would say that if 7 out of 10 are strikes, then that would mean that 3 out of 10 are non-strikes. So these are our theoretical probability. Okay, and then we want to design a simulation that can be used to estimate the probability that Mandy's next pitch is a strike. So we want to do something to generate just completely randomly where it shows that our probability is 7 out of 10 is going to be a strike and 3 out of 10 is going to be non-strike. So what we can do is most calculators have a random generator, a random number generator. Okay, in class, if you guys want to see where your calculator has a random generator, I can show you, hopefully. Hopefully you don't have a super random, weird calculator. But anyway, so if I were to say, let's say we were using a random number generator. It just spits out a number between 1 and 10, or 0 and 10. Okay, so let's say that numbers, if you roll a number between 1 and 7, that represents a strike. Okay, and then I can say between 8 and 10 would represent a non-strike. Yeah. Okay, non-strike. So I want to know where, well, I figured out a random generator. So if I say I were to do this, and each time you hit the random generator button on your calculator and it gives you a number, we're going to say each random number represents one pitch. Okay, so the steps for for creating a simulation is describe an appropriate probability model. So we said that random numbers between 1 and 7 are going to represent a strike, and the from 8 to 10 is going to represent non-strike. We're going to define what a trial is. So each trial is going to be each time you do a random number. And then we're going to say, let's say, for example, we're going to do 50 trials. And then one pitch, one trial represents one strike, or one pitch, sorry. All right. You guys can probably make this look a lot more organized, your thoughts, but that's the gist of it. So you guys say which of these looks like an appropriate simulation for Larry's late bus. Hopefully you guys see that. Okay, the last thing we want to do is conduct and evaluate a simulation. So we're actually going to do it now. Mandy is a pitcher on her school softball team. Last season, 70% of her pitches were strikes. Conduct a simulation that can be used to estimate the probability that Mandy's next pitch is a strike. So we already just talked about how we could do this. We want to do an experimental, right? So we said the numbers from 1 to 7 we're going to represent strikes, and then from 8 to 10 are going to represent non-strikes. So I'm going to make a table here, and I'm going to do tallies. Okay, and let's say we're going to do 30 trials. Okay, so what I'm going to do is I'm going to show you the online random generator. What I did is I went to Google and I just typed in random number generator and it gave me this box here. So I want to pick numbers between 1 and 10 and I click generate. I got 6. So I'm going to go to my table and I'm going to mark between 1 and 6. I got 6, right? So that's between 1 and 7. I'm going to put a tally there. And I'm going to do this 30 times so that I can get an idea of the theoretical probability. So I'm going to stop the video here and go through and do those 30 trials and just make my tallies, and then we'll come back and analyze it. Okay, hang on. Okay, so I did my 30 trials and kept tally of the number of times the number came up between 1 and 7 and the number of times something came up between 8 and 10. And I got 20 times for 1 and 7 and 10 times for 8 through 10. So my experimental probability is, well, I got 20 out of 30 for a strike. Can't spell for the life of me. Strike. So that's going to be 6.6 or 66.6 repeating percent. Okay, so 2/3 is 66%. So about 67% of the time, she was throwing strikes, which is kind of close to what was estimated. And then for non-strikes, it was 10 out of 30, or 1/3, which is 33.3 repeating. So we can say that's about 33%. Okay, so that's about right. So the probability using this the simulation, was about 67% chance that her next throw is going to be a strike. Okay, and that's the difference between experimental and probability, or theoretical. So you guys conduct the simulation for this one, and then you can use that to estimate the probability that Larry's bus is going to be late if it's late 60% of the time. So you guys can use the online generator, or if you can figure out the random number generator on your calculator, you can do that. And I want you guys to do at least 30 trials. Okay, so I want to see you guys in the box. You can type up the number of times that you got. Write out how you set it up, how you set up your simulation, and then what you got. Okay? And that is the end of lesson 12.5 on simulations.